it's very interesting if you think of specialty chemicals, as they add a lot more value to the same commodity chemicals that they come from. And if we look at the impacts that the market has over the past year, we see some of the key global trends, including regional shifts in demand, such as Asia Pacific now growing much faster than Europe, as well as thinking about not the developed but the developing economies. We see that around twice as much growth as the rest of the world is going to come from Asia Pacific. Also, if we think of changing demographics such as aging population, however, healthily aging population, also the demand is going to evolve based on their needs. Some of the other opportunities are digitalization, as well as automation and decarbonization, where each of these places is where some of the specialty chemicals are finding applications. If we think of consumer awareness and understanding, it is now catching up with corporate awareness, as we can see in the case of PFAS. Some of these regulations are getting stricter and stricter. And if you think of the chart on the right, what we are seeing is that around 35% of the US water systems will have to be incorporated with some sort of PFAS treatment, compared to just 10% in 2023. If you think of some of the startups in specialty chemicals, you see there are various ways that some of these companies are trying to evolve, such as using algae, microalgae, as well as spent coffee beans, or using lignites from biorefineries and making them into products that are going into personal care, medical, health and nutrition products. Some of these are very high value products. If you think about the biomaterials, although we see that a lot of them are going to see high growth, but it'll also have to be dependent on some of the end markets and how those end markets are doing. So if we think of applications like ethers or acetate or typecode, we see that the ethers and acetate are much bigger, much larger markets, and are growing much faster than some of the other markets. So moving on to the panel here, I would like to take this opportunity to ask the panelists to please introduce their companies and their offerings, and where do they stand in the specialty chemicals value chain. And I will start.
Sure, thank you. First of all, thank you again, ADI, for inviting us today here with you. Thanks to the audience for sticking around. If it's your day 3 or if it's your day 1 to chemicals, welcome. I'm with AspenTech, and AspenTech is actually a software company, but we work with across the board of chemical industry. We work with bulk manufacturing chemicals, we work with the specialty chemicals, and with polymer companies. You probably know our brand. The company started over 40 years ago as a project in MIT, and since then has grown to a multi-billion-dollar company. Recently, we got acquired by Emerson. That's public knowledge, so we'll soon be an Emerson company. And that gives us the capability to better serve the industries. We provide industrial software from a process simulation and modeling to when it comes to the manufacturing side of things, things like advanced process control, things like supply chain management, MES systems. We provide OT industrial data fabrics and equipment health monitoring. And one of the very recent areas that we have been heavily involved in is digital grid management. We talked a lot the past 2 days about the importance of microgrids and how to manage the power grid when there are so many distributed sources and consumers of energy are coming online.
So, thank you, Anna. Rob, why don't you introduce Meridian, and where does it fit and what does Meridian do?
Yes. Yes, Meridian Chemicals is a private equity company. It is non-institutional, so it is a family shop. We focus on really real biomaterials. So our emphasis right now is in pine chemicals. So these are chemicals derived from pine trees, and we get our raw materials by working with paper mills, and we take the pulp. Really, it's the residual of the pulp. I tell people you make pulp, you get all the liquids, all the sap out, and then it's that material that's our raw material to make the bio-based chemicals from there.
Thank you, Rob. So, where do you see the primary focus for some of the where your product ends up in? Which are the end chemicals?
Yes, these pine chemicals, they end up in many useful applications. That includes paintings and coatings, adhesives, even in the oil field. I mean, several you're familiar there. Some of the chemistries, the downhole formulations, you look to use bio-based materials, and a lot of these pine chemicals are used in this situation. When we look at it, what I've seen over time in my involvement in the industry, and I should have mentioned our company started in 2015, so we're relatively new, is that historically pine chemicals has been competing with petrochemicals, specifically hydrocarbons in many applications. In reality is the hydrocarbons availability market is so big, and pine chemicals is very small because it's a limited resource. In fact, I saw on my phone earlier today yet another paper mill has closed. Is announced today. So every time that happens, that's less raw material essentially available for these products. So we look to make sure that these products are really focused. And in our perspectives, we want to work with hydrocarbons and hydrocarbons formulations and get some of these pine chemicals introduced so that we can improve the sustainability of those types of formulations, improve the properties, and really keep the cost structure and the availability of supply to a large amount of consumers.
Thank you, that's helpful. So, Anna, you mentioned the recent development in form of Emerson acquiring the company and how you're now looking at grid management as an offering as well. What are some of the other strategic developments that you see or initiatives that you see that are going to be more tailored to how the chemical industry is evolving?
Absolutely. So, as Uday presented this morning in their talks the past 2 days again in the conference, the chemical market is going through a downturn, unfortunately. So the 2024 and 23, the volume of manufactured chemicals in the US has been negative, right? There has been shrinkage in the volume. So there is hopes for 2025, but that just underscores the importance of efficiency for chemical manufacturers. So anything that contributes to faster time to market, to more efficient processes, using less energy, and of course complying with all the sustainability targets that chemical companies have set for the 2030 and 2050. So anything that helps the industry, we all for it, and we have been in this business for years, right? So our simulation and modeling softwares have been used to improve the energy efficiency, the efficiency of the utilities used to produce heat or the cool necessary for the processes. So those are some of the common themes that we have been working for the industry. Through the advanced process control, I mean, we have been able to work with energy-intensive processes, for example, some on the refining side, some on the olefin cracking, but also some on the specialty side to reduce the energy use and reduce the emissions as a consequence of that. So
I think that's helpful. So, Rob, Meridian focuses on crude tall oil. So, can you talk a little bit about what that is? What are the ways that you produce it? Is the paper pulp the only source, or how are you seeing the feedstock going forward?
Yes, feedstock's a challenge because this is residual waste from a paper and pulp mill, and specifically the ones that use pine trees. So you're looking for the softwood. That's primarily in the southeastern United States. And when you survey all those paper mills, some of them combine them with hardwood, which essentially contaminates the feedstock. So we want to get the good softwood, and I just refer to as good tree sap out of there in order to make our chemistries. And then the beauty of that is it's a very circular and sustainable process, because we're able to extract and react and make useful chemistries, primarily starting with the CTO, or crude tall oil. And the rest of the waste from that process is recycled back to the pulp mill, where they can basically not buy as much chemical makeup for their own pulping process. So as a result, when we take these chemistries and we manufacture crude tall oil at the paper mill, it comes out with essentially zero carbon emission at that stage. And from us moving that product around, it's really the transportation emissions that are the first carbon creations in the process.
Okay, that's helpful. So another question for you is, how are some of the ways to improve efficiency or reduce costs that you have seen in the chemical industry today, and how you have helped your clients?
Sure. So we have to look at the entire value chain of the chemical manufacturing, right? Mm-hmm. From the raw materials, from the supply chain to get that raw materials, to bringing it, do the R&D work to actually create the product, manufacture it, and then take it out and distribute it to the customers. So there are opportunities for efficiency and faster time to market at every step of this. So we have helped, for example, this is actually a recent example. We helped Dow Chemical through one of their specialty materials production line to improve the transition during the manufacturing and supply chain part of things through collaborative scheduling. So in a chemical manufacturing facility, there are maybe less than a handful of people who have access actually to the scheduling and know what's going on. But then if you make a tool that makes scheduling actually a collaborative effort, now the maintenance has visibility over the scheduling, now the engineering team is visibility over the scheduling, that can actually expedite this process and the manufacturing process. So that at the end of the implementation of this collaborative tool, they reported that they're able to increase 20% their throughput, which is huge. The other example I can give you was through batch manufacturing. That's also a very recent case. We worked with DuPont. They had a batch manufacturing process, and they were not able to fully control and stabilize the process. So every batch that they were making, there were some inconsistencies from batch to batch. So we helped them through implementing a hybrid model, which is basically a combination between first principle engineering model and an AI tool. And that implementation helped them to actually make their batches consistent and realize what are the bottlenecks for having a consistent production. So, and then you can take it to actual, if it's a continuous manufacturing, you can use APC to do that, and so on. So there are a lot of opportunities. It really depends on the process and to do the work.
So it is a tool that can be made available to a wider team than just the people who are responsible for scheduling.
Absolutely. So it's kind of like a Gantt chart. So every team involved in that production process can actually have visibility over the schedule and actually can comment and coordinate. So through that collaborative effort, now they can improve like the manufacturing time.
That's interesting. Thank you. So, Rob, you mentioned that paints and coatings, oil field chemicals, these are some of the end markets for your products. Out of these, which one do you see the most growth in the medium term, and how do you see some of these markets evolve in terms of their appetite for bio-based chemicals?
Right. In specific applications, one that intrigues me is road markings. I like to tell people if you're driving down any street and you see kind of a paint, whether it's the white stripe or the yellow, and it's kind of wearing out, that's probably an older technology. But if you see where the stripes are on the road and it looks like they're put down by a sticker, they're very thick, that's generally the pine chemicals technology. They're becoming more popular because of these self-driving vehicles, because you need to be the eyes of the vehicle, so to speak, have to be able to pick up the road markings very quickly and very succinctly. So these types of markings are better. Plus, there's some pixie dust you can sprinkle in there to actually make them reflective, which benefits us nice, especially people like myself. You get older, that night vision's not quite there. You like to see the reflection. The other application is some of these chemicals tend to be non-allergenic, or at least less allergenic. So they're used for the adhesives on diapers, baby diapers, and one of the markets is expanding because it's a good thing we're all living longer. There's a bigger market for adult diapers, so that's actually another application. But my most exciting part here is really looking, as I mentioned earlier, it's kind of the combination. I think historically it's been a fight between pine chemicals and petrochemicals, specifically the hydrocarbons. And there's just so much opportunity to utilize the properties of some of the pine chemicals, sustainability being one of the top ones. And there's other tackifier and other properties that lend to these formulations that can make better adhesives and better paints and better coatings as a result.
Thank you, that's helpful. So, Anna, for you is, for some of your clients, how are their needs changing, and how is Aspen kind of adapting to those changes in needs?
Gosh, there are like so many things happening in the market that where do you start with, right? So with all the things that happening globally in geopolitics, then you have a generation that we would call them digital natives. So they're very young engineers that they're not used to the traditional operations of the plants. Then there's the ever-growing demand for chemicals. Then there is the demand for more advanced materials. Now, we talked about all the developments in EV batteries. There's all talks about like the data centers, their need to even faster operating chips. So that needs a whole lot of electronic chemicals, right? So the market is, I would say, there's like the perfect storm, and there are all kinds of opportunities to actually grow from there. So, but again, going back to the initial comment I was making, the key here is increasing efficiency, lowering cost, improving time to market for the manufacturers, and improving sustainability metrics. I think this is something that the entire industry is behind it and looks for ways to find and actually doing it.
That's helpful. So, Rob, coming back to you, I know we talked about how specialty chemicals are somewhat more resilient to the market than some of these commodity chemicals. But also on the flip side, the customers also want some sort of a supply security. And when you see a market for feedstock that is shrinking, how does that impact how your customers see pine chemicals? Are they like, would they look for an alternative? How difficult or easy would it be to say replace some of these chemicals in the end products?
It is a challenge, because security of feedstock is important all the way through the chain. And it's really understanding the markets, the growth markets, and working directly with the customers and their innovations. And one way to kind of spread the wealth is what I said about working with hydrocarbon formulations and making that spread a bit, because there's not a lot that can be done about that source, because over time we're a digital economy in a lot of ways. We're using a lot less paper. Several of you are taking notes on the iPads, and we don't have as much copy paper and that around. And those are resources that would be really helpful in this industry. But what I really want to say is the aspects that we look at is best use of the molecule. And that's usually going to be the best value use through that supply chain, and that's really where we're going to focus to make sure we have the security of supply for where it counts.
And do you see a lot of pull from, say, the fuels used, like in renewable diesel, or say in sustainable aviation fuel, for this crude tall oil? Well,
this certainly qualifies as feedstock for the biofuels that we spoke about yesterday. And we went through about a year and a half ago where there was great demand, and people would come to me and say, "Hey, I hear you have like pine chemistry," and get excited. I try to tell them what we have. "Oh, never mind, we'll just buy it all." And that was really the focus, and that's really with the government incentives, and they got so high. And sure, we did, a lot of people sold some product, but then like a lot of the fuels markets, it's very cyclical, and it went from like terrific to almost nothing. And that's when the government incentives start to be relaxed and the ticket prices started to lower. So really it's about that sustainable placement of material. Now, when we look at this, when we look at these products, we work very hard to make sure that we can represent them well. And a lot has been done to make sure you have the feedstocks and they're legitimate. So we make sure we have that sustainability through we qualify on ISCC, the International Sustainability and Carbon Certification. So we make sure that we comply with that. We actually work with ISCC and suggest, because what happens, especially when you have those government incentives, not only do the supply chains try and figure out how do I get that free money, but other traders and others who have nothing to do with it figure out how can I get in there. So it's really important that we can actually have traceability and mass balance from the pine tree and quality control all the way to the consumer base to make sure that that's done properly.
That's helpful. So, Anna, when we talk about implementing some of your technologies on an existing, say, asset, what changes would, say, an operator need to make, or how big of an investment would that be? Or would it be just implemented on existing tools or equipment that they have?
So that really would depend on the maturity of the asset, right? Because like in the chemical industry, so McKinsey years ago published a curve that was actually showing like which industries are ahead of industry in terms of digitalization and which industries are behind, and chemicals is certainly one of the industries that is falling behind in digitalization. So across the board, and you look at like the chemical manufacturers, depending on the size, the products, and quite frankly, how deep their pockets are. I mean, there are different stages. So I personally used to work for an S&P Global company that their share of digitalization was just a historian in my past career before joining AspenTech. So, and then there are certain companies that are very eager, very tech savvy. They're constantly following what's the newest trends. You heard from the previous speaker that that they're already starting using their own AI tools to actually be able to help them speed up through the product development. So that's a very broad question. So it really depends where they stand, what part of the process they're trying to improve, and what's their end goal, where they want to be. So that I wouldn't say that there is no one size fits all answer to that.
So do you find synergies between, say, AspenTech's offerings and Meridian's facility to kind of see how they could be fit with each other.
I mean, Rob just mentioned about the challenges they have with sourcing like raw materials, right? So I would say like a resilient supply chain is one of the challenges that your production line has. So certainly yes, and then it comes to manufacturing and so on. Yeah.
And Rob, do you see some of the, so Anna already mentioned supply chain resiliency. Do you see any key areas where some of the tools such as these could help you?
Well, certainly, because you need that execution consistency. I liked what you said about the collaborative effort. That's what's often missing, because you need that bit of information, because the maintenance, yes, things break down, but you want to have predictive maintenance as well through the processes. Uptime is important, and also when you do that, the quality controls internally are important. And we're used to just lab testing and stuff like that, but really it's any inline measurements that can kind of keep the process in control, and it really helps the yields and utilizations. So much less waste and more efficiency. And let's face it, even if you're, we talk about commodity specialty, you still have to be sharp on specialty chemical production. Yes, you're trying to meet people's needs. Maybe we're doing some specific things, and that makes it higher value for the chain. But you have to be consistent. So that really goes through all the processes, because even if you get, people are willing to pay a little bit more, there'll be someone else out there that's going to try to copy it, either in kind or some other way. So your best method, you've got to be able to develop your chemicals in your processes. I would tell my teams, if we're selling the same chemistry in the same package 18 months from now, we're probably in trouble. Okay, and that really focuses all the way through. So the more you can have control of your process and be able to make the adaptations with these types of technology, I think is going to be much better for your companies.
That's helpful. So Anna, like Rob mentioned, predictive maintenance. So how do you see the push from customers or even internally on AI versus Gen AI in your offerings?
I would say in general, everyone, especially after the generative AI that coming to market the past couple of years, everyone is interested. But the key here is how do you are intending to use that AI? Because especially in industrial applications, you need to have some kind of guardrail. For example, if you're trying to use AI to optimize the process of your reactor, make sure at least that you are covering the mass balance or the heat balance of that operation, right? So that's why we believe that the AI has to be guardrailed by the first principle engineering. If the first principle engineering is not there, your AI application may or may not give you the right answer. And how do you know that, right? Mm-hmm. So that's certainly one of the things that everyone is interested. But in general, I would say, considering a lot of chemical companies are behind the digitalization curve, first they need to upgrade some of the basic infrastructure, right? So they have to pass beyond the basic DCS control system to be have some visibility over their operation, and frankly, turn it into like more profitability for their operation.
That's helpful. So I'll open it up for the audience. If they have any questions.
Our website.
Thank you, Rob. So what happens when feedstock runs out, when people completely stop using paper? Probably it's a doomsday scenario, but you can't just go further upstream to the pine trees and extract your feedstock?
Ultimately, I believe that's a possibility. But for now, with the like they call the Amazon effect, with the need for brown board and cardboard. These are paper mills that use pine trees, and that gives us some real hope, and that those materials will be placed. I think equally, it's the challenge with the the feedstocks into the biofuels. It would be easy to say, oh, you know what, I'm just going to invest in here and just push everything into the fuels. And if that's the highest value over time, then free markets, that'll be it. But there's such an oscillation there. And so really the challenge is to find out where it should be placed. And that's why I said that the age-old conflict of pine chemicals competing with hydrocarbons, it's a silly fight, because there's so much room for everybody in there. And many of you in here have chemistry backgrounds. Chemistry solves a lot of problems. And I think someone said, hey, the problem isn't these chemicals, it's the emissions and how we control that. And certainly with the process that we have here, the development of pine chemicals, that's very circular. And that's going to lend to, I think, better improvements through many of the specialty chemicals going into these areas.
So it feels like you're not too excited about this demand for your feedstock that biofuels is creating. Do you see demand for biofuels changing and potentially the draw on your feedstock if, let's say, subsidies weaken or subsidies go away? I guess, how do you see that dynamic going forward?
Well, they will, and they have. And like I said, it's not a problem per se, but what happens, like when we went through this about a year and a half ago, the supply changes, our industry in general, you start cutting people off, so they have, they don't have the confidence that you're going to be able to develop and be there for them for these further developments. So it's really a matter of segmenting that. I'm not saying don't produce in that. I mean, it's going to be useful, but you got to understand the cyclicality and where the best uses are. That's a responsibility up and down the value chain. So no, I wouldn't put a stop sign up for that. But then when you really dig down into these pine chemistries and you dig down into the tall oil that's produced, there's different grades and qualities. When you're in the southern part of the U.S., it's a much higher grade CTO. There's CTO produced in the northern climates in Canada and Scandinavia. It's a bit of a lower grade. You can do less with it. And what we could do as an industry is segregate that and use it for the right uses. But what we see is when people are pressured and they're in a hurry, they kind of lump it together. Good procurement people, they're trying to commoditize everything, to get the lower prices. So there's a lot of confusion. So if we get together as an industry and really make sure that we utilize our resources properly, I think everybody will win. And then for the biofuels, it's a matter of what they're doing. Got to have other feedstocks, because we can take every single molecule with the objectives of biofuels. We can put every single molecule that can be created in these biochemicals, specifically pine chemicals. We can put it all into that industry, and that's still not enough to meet those growth objectives.
Thank you.
Okay, Tom.
So when you think about the energy market, upstream and midstream, there's been lots of consolidation, and in the paper world, it's happened too. Got the Smurfits and paper excellences of the world. So I guess for both of you, how has consolidation of, whether it's oil and gas producers, paper companies, chemical companies, how has that consolidation of your end user or end client impacted the business, if at all?
So I would say that the consolidations, it makes collaboration easier between, and it makes sharing the resources easier also. So there has been, and the other thing that is happening, you mentioned the energy industry. A lot of energy companies nowadays are interested to own a piece of chemical industry. So there is a huge push, especially out of the Middle East. So the Middle Eastern national oil companies, they have a huge appetite to acquire chemical companies in Europe, in US. And I think ultimately it's good for the chemical industry because it helps them, speaking from the digital infrastructure, if they're behind, the investment that comes with this kind of merger acquisition actually helps them to upgrade the infrastructure. It gives them better resources to operate. So I think overall it would be a positive impact.
Yeah, and as you know, those of you who've been around long enough, we've seen this movie before. I mean, you get into the, hey, we have to reach upstream and downstream and become a bigger company, and then you get to the modes of, no, we got to separate everything out. I think we're just seeing that cycle. So to me, I just shrug my shoulders and say, okay, we're going to go with it. And for a smaller company like ours, I mean, it's really that we have to be expert on what we're going to be expert in, and then we've got to partner, with the right people and the right functions in order to place these chemicals in their most optimal places.
I think it is an interesting point of view because Ricardo earlier today mentioned a very different point of view where larger companies are a little slower when it comes to, say, adapting. So this is interesting that your point of view to some level has been on the flip side as well, that it also increases the appetite for, say, innovation and more investment in technology.
Yeah, I mean, I think that overall, like Rob mentioned, I mean, we heard like this last week that the Honeywell is splitting into 3 companies, right? So this is kind of like a cycle that let's get big and then let's split and then let's get big again and split again. So that seems happening quite a bit.
That's interesting. Yes, sir.
Yeah, this is a question for Anna. So, Anna, there's like tremendous disruption that's happening in the chemical industry, right? I mean, you are seeing a lot of pressure in terms of feedstocks, in terms of recycling, in terms of new end markets that are opening up, overcapacity in China. So, and then, you also talked about how the footprint of digital and software in the chemical industry relative to other industries is low. So, I mean, given all this, how does product development look like for a company like AspenTech? Like, how do you look at innovation, coming up with new products and new software? Like, how does that look like for a company like AspenTech?
So we, like I said, everything we do is try to help our clients to improve efficiency, and that efficiency trickles down into their sustainability metrics, their bottom line, and how they operate. They can operate with fewer number of people, bringing in AI tools into our products. It helps young engineers, bringing operator training systems, for example, for this new generation that is not used to working in a chemical plant. I mean, that there are things that are that's how we're approaching to helping our customers actually run their facilities more efficiently with lower cost and lower environmental impacts.
But how does that? How do those needs flow into AspenTech? It's primarily through feedback that you get from users. I'm curious, like, how does that feedback work?
So in AspenTech, we have advisory boards, and advisory boards are either energy advisory board or chemical advisory board. They are big players in the market. So we get with them every quarter or every 6 months, and they provide feedback of the challenges, of real operational challenges that they have. So for example, one of the things that came out maybe like a couple years ago, 3 years ago or so, was we developed an emissions management tool for the olefin, specifically at refining industries. That came out of a real need that they needed to do carbon accounting. They understand what is the carbon footprint of the cracking process or of the refining which ones are the major emitting sources and how can they mitigate that. So I think for a company like us, the best way is actually collaborating with the players in the market and understand the real pain points that they have.
Thank you.
So Rob, for you, I have a question. So we do talk about like bio-based and sustainability. So in your end products or your end customers, do you see that is the goal just hitting that critical point before they can call it, okay, it is sustainable? Or are your customers willing to go a little bit more in terms of what their intentions are or commitments are towards incorporating bio-based materials?
That's what the key is, and in our area, I think it started in Europe. We rate ourselves with EcoVadis, and we rate that entire supply chain, and we make sure that we can comply and do our testing and everything, and we actually rank in that process as platinum, which is top 1%. So we're very proud of that for a small company that we can do that. We work very hard to make sure of that. But in order to maintain that, it's really up and downstream, because we all have to be excellent in that process, and that in itself adds value. It goes back to what I was saying. We got to get these products and chemicals in the optimal places. Then as a full society will benefit. Now, obviously, people said it earlier in the sessions, hey, it's all about making money. Yes, it is, and you're going to make the most money when you have these optimal placements, you have the good yields, and you know where they're ending up. So what the customers do is we looked at, hey, you got to make things better, you got to make them less expensive, but you also have to improve the properties. And it's these chemistries and these types of additives and these type of combinations with pine chemicals and other aspects, not too unlike what we heard from compounding, that really is going to help this industry and help it become more sustainable, not only in security of supply, but environmentally as well.
And on the same lines, Anna, so like Rob mentioned, like maintaining or making sure that you have the right elements across the value chain. And ISCC Plus is something that you mentioned. That is something that we've been working on, because that's one of the key ways for some of these operators to kind of track how much biomaterial ends up in their end products. So, and a lot of that depends on mass balance and maintaining those. So is that an offering also that AspenTech has to kind of across the value chain, being able to just keep a track of how much biomaterial is ending up where?
Sure, that's actually one of the initiatives that we're working on, to do the life cycle assessment, be able to do that for our clients. And that's a huge need right now in Europe, as you know, because they're required to actually report and see if they qualify for if their product is called bio-based or not. So that's one of the things they're working on. As you said, it's a combination between supply chain tools, it's a combination between carbon accounting and the manufacturing. So yeah.
Okay.
Well, that'd be very good to see that, because I can tell you one of the things. This all sounds very good, but when you get into it and you work with the agencies and you need to measure things. One of the frustrations I've had is, you need to measure your carbon, you need to measure your transportation. Okay, well, how do you do that? Oh, we don't know. You do it, you submit to us, and we'll tell you if it's right. I mean, it's crazy. So the idea is good, but there's no standard behind it. And I just got my mass balance stuff out and got to do my chemical engineering work that I hadn't done for 20, 30 years, and I had fun with it. I don't know if it was correct, but I produced something. And then it comes in. So we need some help. I think the industry needs some help. All these ideas are very good, but we need to have standards on those measurements for many, many reasons.
And then do you see agencies trying to, say, work towards standardizing some of these procedures, or how do you see the next 5 or 10 years for standardization around some of these processes.
Yeah, I think people work really hard on the what, but not the how, and that's where more standardization is needed. So you don't double count, and you understand what that everyone wants to take credit for everything, right? That's kind of the society we live in. But we have to understand where the handoffs are. Mm-hmm. We have to get credit for those handoffs and make sure that we have that, whether it's in linear or if it's in a circular. But that's what we have to really have more confidence in, I would say, going forward.
Anna, you have.
I agree with what Rob said. I know that there are a lot of efforts that either from the manufacturers themselves or from companies like us. So everyone is trying to come up with ways to correctly do these kind of accountings, but I don't think we're there yet. So I think at least a few years still until to the point that we can say we have these kind of reliable tools that absolutely can use.
It's almost, I can relate because it's almost at the end of the forum. It's all of us are going to take credit. We're going to give credits to the audience, speakers, Faiza. I'm going to take credit. So I can imagine everybody wanting to take some credit for any success that we see. So I think we are at time. This was a very interesting panel. Lots of positive ideas as well, and actually pointing out the problems where we could maybe work on some solution by the time we meet again for the next year forum. So thank you so much.